Most buildings today are collecting more data than ever. Thousands of points, years of history, trend logs everywhere. And yet, most building owners still don't know if their systems are actually working the way they were designed. This is not a software problem, and it's not a hardware problem. It's a decision problem. Because trending everything doesn't mean you're trending the right things. If you work with building systems, mechanical, electrical, plumbing, or controls, this channel is for you. Welcome to Building Science Analytics. So what is trending actually for? Trending exists for one reason: to provide behavior over time, not to make dashboards look impressive, not to fill up storage, not because we can. Trending is supposed to answer very specific questions. Is the system doing what we intended it to do? Does actual operation match the engineering assumptions? When something goes wrong, can we prove when and why? If your trends can't answer those questions, they're noise. Here is what I see constantly in the field. Every temperature sensor is trended. Every command is trended. Every status point is trended at 5-minute intervals, forever. It feels thorough. It feels safe. But in reality, it creates two big problems. First, you drown in data and miss the general signal. Second, you never trend the relationship that actually proves performance. Most building automation systems don't fail because a sensor stops working. They fail because systems interact in ways nobody is watching. So if trending everything doesn't work, what should we trend? Start with outcomes, not commands, not intentions, outcomes. Space temperature, space humidity when applicable, discharge air temperature, return air temperature. These are the results the building experiences. If you don't know how the space actually behaves over time, you don't know if the system is working as designed. Everything else is secondary. This is where control effort comes in. Control effort answers a different question. What did the system have to do to achieve that outcome? What is the valve position, damper position? What is the compressor speed, or how many stages are enabled? What is the fan speed? If the space temperature looks fine, but your valve is pinned at 100% all day, that's not success, that's masked failure. What it tells you is that the control loop has lost authority. The system is demanding everything the equipment can give just to stay even. That could mean undersized equipment, poor coil performance, dirty filters, bad airflow, or an assumption in the original design that no longer matches reality. Trending outcomes alone hides all of that. Trending comfort effort exposes it. Control effort still needs context. This is where mode and enable signals matter. Occupied versus unoccupied, heating versus cooling, economizer enable, optimal start, freeze protection. These points explain why the system behaved the way it did. Without them, trend data becomes guesswork. Intent matters. Once you understand outcomes, effort, and intent, energy behavior shows you how expensive that operation really is. Some points don't earn their keep. Values that rarely change, signals with no context, data logged just in case someone might need it later. If you don't know why you are trending something, you won't know how to interpret it in the future. Bad trending just doesn't waste storage, it hides problems. Systems limp along for years, meeting space temperature while burning energy and wearing out the equipment. Engineering doesn't end when the drawings are sealed. The building is the final exam. Trending is how you read the results. If you don't trend the right things, you can't prove your assumptions worked or learn when they didn't. For any system, ask 3 questions. What result am I trying to achieve? What effort does the system apply? What mode explains the behavior? If a trend doesn't help answer one of those, question why it exists. Data doesn't create insight. Judgment does. If you would like to learn more about building systems, consider subscribing. Better buildings come from better understanding. This is Building Science Analytics. I'll see you in the next video.